Foundations of Amateur Radio. Last week I was casually asked, what is a resistor? Now, if you're into electronics, like many radio amateurs, you'll instantly have a picture of a little blob with two wires with pretty colours painted on the outside, the size of a grain of rice, and if you're not into electronics, you now know what a resistor looks like. Before I talk more about resistors, I'm going to talk about a stick. If you pick up a stick and poke something with it, some interesting stuff is actually happening. You move your hand at one end, and the other end moves at the same time. Obvious, right? It's a stick. On a molecular level, something else is happening. The atoms under your hand inside the stick move back and forth with your hand as you move it. The atoms next to those atoms do the same thing. The atoms next to that, all the way to the end, also do the same. Now, you likely have a picture in your mind of a solid stick. On a molecular level, this isn't solid at all. Instead of a solid stick, imagine having a row of ice cubes with a little space in between each one being bumped by the previous ice cube. The ice cube closest to you moves with your hand. The one next to that gets bumped all the way to the end. With ice cubes, there is a noticeable delay if gaps are visible, but the delay gets smaller and smaller if the cubes are closer and closer together. In an electrical wire, a similar thing is happening. You might have a picture in your mind of electrons travelling from one end of a battery through a wire to the other end of a battery. Except that's not what is happening. While electrons do move, very slowly, it's called the drift velocity, think centimetres or inches per hour, turning on a light is instant. It's instant because each atom affects the one next to it, which does the same to the one next to that, and so on. While not exact, this happens roughly at the speed of light. This is beginning to look a lot like a stick. Push at one end, something happens at the other end, almost immediately. Instead of ice cubes, but in much the same way, we're actually moving an electrical charge from one end of a wire to the other. It takes energy to keep a charge moving along a wire. The amount of energy used is the resistance of that wire. Not all materials act in the same way. Some, like silver or copper, use little energy or have low resistance, while others, like carbon, use more energy and have high resistance. You'll find resistors made in many different ways of various different materials. Each one is made for the specific purposes of using a defined amount of energy to pass along a charge. There are resistors made of carbon and of thin film of conductive material, sometimes with laser cut paths to make them appear as a long maze of conductive material, and a very thin wire tightly wound together. This kind of wire resistor has a side effect in that a tightly wound coil like that has some properties that we use in amateur radio. We often think of these kinds of devices as inductors, but that's another story for another day. As a side note, I started using coulombs, joules, volts, amperes and ohms to explain this, but I figured that it wasn't needed to understand how it actually works. If you have some time, look into it. The maths is fascinating and pretty straightforward. I'm Onno, Victor Kilo 6, Foxtrot Lima Alpha Bravo.